Yeah, can you see the screen? Okay, let us start. I hope everyone can hear me clearly. Is that?
Sir.
Okay, good. So in the last class, we discussed few of the terminologies, especially hazard, and then we proceeded in order to explain the difference between the terms hazard and disaster. So hazard, as you can see, again, just I'd like to a little bit refresh your memory. It's a natural event when uh, there is nature, everything is stochastic. That means there is a probability of occurrence of all these things. And then when these kind of natural events occur, which have the potential to cause damage in terms of properties and lives, and a long-term damage in terms of livelihoods and services, then it is termed as a hazard. And when these things actually do occur, then it interacts in an adverse way with the day-to-day lives of the society. At that point of time, it translates into a disaster. So, as you might have seen yesterday, there was an earthquake. So, if the earthquake uh, came and then there were shaking of buildings, and then there were no buildings damaged, and then there were no lives lost, then it would have been just a mere hazard. But if the earthquake came, then there were damages to the structural units in the building, and then this damage, there were loss of lives or loss of properties. At that point of time, we can tell it as an earthquake disaster. So, everyone, I don't know, did you feel the earthquake yesterday?
Yes, sir.
Sir.
Ah,
Sir.
yeah.
Yes, sir. Even in Itanagar also, in Arunachal also.
Oh, yeah. So it was actually a big earthquake. I
Yes, it
hope
was.
I hope you already are familiar with the causes why this kind of an earthquake they come. Normally, this is the plate tectonics. Our art, whatever we see, wherever we stand, wherever we erect our buildings, wherever we see trees, uh, or other buildings, or any other infrastructure, it is situated on top of the crust. And then this crust actually moves on top of the molten magma. So this molten magma is very volatile, that is deep inside the earth. And then as these molten magmas they move, these crusts also they have a tendency to move along this molten magma. So in the process, they collide with each other, and then the process, this energy is released. So if it happens in a subduction zone, then one plate may be going above another, and then in the process, tremendous amount of energy is released. So this is the origin normally in case of an earthquake. But there may be other reasons also why earthquakes do take place. Okay. And whenever this kind of an earthquake happens, a tremendous amount of energy is released. So we measure this amount of energy in terms of the magnitude of the earthquake. So there is a scale known as the Richter scale, and then it goes up to 10. So 10 being the maximum. But up till now, there are no recorded earthquakes with this much of magnitude. So yesterday's earthquake released an amount of energy equivalent to, somebody is saying 6.2, somebody is saying 6.4, and some estimates it is around 6.7. But when I checked the USGS site, that means United States Geological Survey, there it was mentioned that it is a magnitude 6 earthquake in the Richter scale. But according to some other local estimates, it was somewhere in between 6.2 to 6.4. So anyhow, this comes in the category of earthquake which can be
Sir,
uh,
what survey you have mentioned? What statistics?
okay. It is known as United States Geological Survey. So if you go to Google, you can type
Okay.
USGS. Okay, USGS. Then
USGS.
yes, USGS. So I can share the link also after the class. And then there, every earthquake, whenever it happens, there is a method by which they detect the location of the earthquake. So in civil engineering, there is a technique in surveying known as triangulation. Okay, so by the method of triangulation, uh, they can exactly pinpoint the location of the earthquake, or uh, where the earthquake actually took place. So United States Geological Survey also does that. Some other local agencies also they do it. And then when we have an earthquake, maybe after 5 minutes, the point where the earthquake happened or the epicenter of the earthquake is shown in a map in their website. So yesterday's earthquake, when I checked, it was showing somewhere on the north of Tejpur in a state or in a place known as Dekyajali, and then the fault is known as Kopili fault. Okay, so there are many major and minor faults. This is happening on a minor fault known as the Kopili fault. And apart from that, the earthquake is termed as a shallow earthquake. So it is a representation of the depth at which this rupture or the epicenter of the earthquake lies. Okay, so there are different standards where you can say this is a shallow earthquake or this is a deep earthquake. Again, if it is a minor earthquake or if it is a major earthquake or it is a moderate earthquake. So up to category 7, you can say still it is a moderate. I think by crossing 7, it goes into a major earthquake. So I can also share with you the charts where the different earthquakes are categorized accordingly. So you see, earthquakes are actually all the time, they keep on coming mostly. Uh, but normally, if your building is constructed following the standard norms or the prescribed codes by the authority of a particular country, we see that there are no major damages that happens. Damages means fatal damages. So normally when you construct a building, because you are all going to be some civil engineers, uh, you will know later on that if the building shows some cracks during the time of an earthquake, it does not mean that it is a badly constructed building, first of all. Okay, so you have to investigate or analyze where the crack is appearing on the building. So buildings are constructed in a way that during the time of an earthquake, so that it can absorb that amount of energy, and by absorbing so it allows itself to go some cracks. Normally, if the cracks happens not in the joints of the beams and the columns, or neither it occurs in the beams or the columns alone, but it only occurs uh, in the walls or the non-structural members, what we say. So that means it has performed quite well during the earthquake. In the recent earthquake, yesterday's earthquake, especially in Guwahati area, there was a survey that was carried out, and then it was seen that most of these buildings or the high-rise buildings in and around the greater Guwahati area, they did perform quite well. That means their performance during the earthquake was quite well. Though we can see many cracks that have developed in the walls and the non-structural members mostly. But if you see normally the structural members which are showing cracks, that in that case you have to little bit go deep into the investigation why these cracks appeared. Did really building code was followed, or was the earthquake really very big enough so that these cracks happened? Uh, so you should not always think that by seeing cracks during the time or after an earthquake, we cannot really categorize that the building is badly constructed. Okay, first of all, so remember that. Okay, anyway, again, coming back to the main topic. So yesterday's hazard, as you see, if it did not cause any loss of property, then in that case we could have merely said that this was only a hazard. But when we went to investigate, we saw that there were damages that happened to the buildings, not in terms of lives, but in terms of structural or the non-structural members to some extent. So that involved the loss of property. So in that case, that point of time, this earthquake has or can be called a disaster. Okay, and then we can further on go and then investigate and then say how big this earthquake was in terms of the return period. As you know that all these hazards, they do have a probability of occurrence. For example, if I ask you what was the probability of occurrence of an earthquake with a magnitude of 6.4, uh, particularly in the Himalayan region, then there should be a value, or you can say that there is this much of a probability of occurrence of a magnitude 6 or 7 earthquake in the Himalayan region in the next 10 years. So all hazards, they do have this number associated with them. The bigger the probability of occurrence, the smaller is the magnitude. Or on the other way, if I say if there is a small earthquake, it does have a higher chance of occurrence or probability of occurrence, and vice versa. By saying so, we can say that there is a very low probability of occurrence of a magnitude of an earthquake which is very big in its magnitude. But it does not mean that there are no chance of occurrence, or you cannot say that there will never be an earthquake of magnitude 9 or magnitude 8 which may come in the region. There always remains a probability of occurrence, however small. And then the challenge is that you cannot specifically say that this earthquake is going to come in the next 2 years or in a particular year in the next 10-year period. This is a big challenge in a modern day science. it is not only confined only to the earthquakes, even in case of major other disasters or hazards like floods or landslides or even volcanic eruptions, you cannot be very much sure that when exactly the particular magnitude of a hazard will occur in the next, suppose 10 years, next 20 years, or next 30 years. You can only attach the probability of occurrence. Okay, so you can say that if I measure a flood of that will produce this much meter cube uh, or this much volume of water that will be released into this river, it has a probability of occurrence of 0.02. But when exactly this flood is going to come, it is very challenging job to do. And then we still have not been able to pinpoint this particular year or particular time frame when this can occur or this exactly will occur. Okay. Okay, let us go to the next slide. Then I would like to show you some of the different types of hazards and then their subcategories. For examples, these are all categorized according to their source of origin. These are mostly the natural hazards, as you can see. The first one in the types, you see the geological hazards. So what may be the common geological hazards? Number one, it comes to earthquakes. Because why? We know that the origin of the earthquake is mostly governed by the movement of the plates or the crust, which are all the time constantly moving over the molten magma. So this is something, the subject of geology, okay? Deep into the core of the art. Similarly, you can also turn landslides into the same category. I could see yesterday also there was one video that appeared that there was a landslide on a particular hilltop somewhere near Arunachal Pradesh, which was triggered by the earthquake. So these kind of landslides are known as earthquake-induced landslides. But even there are other landslides which may occur without an earthquake. But whenever we want to uh, class this kind of hazards, normally these landslides also do fall into the geological hazards. Again, tsunami. So we have discussed why tsunami mostly occur, and then the triggering factor is normally an earthquake deep in the ocean bed. So because of the earthquake, a particular fault ruptures, or when a particular fault ruptures, there is an earthquake that takes place. And then if it happens in the ocean bed, a particular column of water suddenly rises. Okay, and then that column of water travels towards the shore at an incredible speed. And then whenever this particular column of water keeps on approaching the shore, its velocity decreases, but the height of the water column increases. And that is why we see incredibly huge and waves that carry enormous amount of energy that slams into the coastal belts. So typical example of tsunamis were the tsunamis that came in the Indian Ocean in the year 2004 that destructed most of these South Asian and Southeast Asian continents, countries which belong here. And then in May 11 2011, there was a huge earthquake of magnitude 9 that came in the eastern coast of Japan, and then this particular earthquake so far triggered the costliest disaster or natural disaster in human civilization, which further led to the Fukushima nuclear plant disaster. Okay, so earthquakes, landslides, tsunamis, everything they can be categorized into geological hazards. Then dam burst. So dam burst sometimes also can be triggered by an earthquake, or there may be other preconditions why it may lead to a dam burst. Normally, what will happen if there is a dam burst? There will be successive flooding in the downstream areas. A dam or a reservoir is constructed to hold water. This water is used for different purposes. Sometimes this water is used mostly for generation of electricity or energy, or a part of it is also used for irrigation. But mostly on the other side of the dam, we see huge amount of water that is being stored. So constantly there is a pressure that is exerted on the walls of the dam. Because of some reason, if these walls give away or the dam cannot hold this amount of water pressure, it will burst. So this dam may burst because of an earthquake or because of a rupture in the dam due to some other pre-existing conditions. So in that case, you can imagine what a catastrophic event is likely to happen in the downstream areas. Huh? So it will be floods everywhere. Along with the floods, there will be loss of enormous amount of, you can see, forest area or agricultural lands or properties. Many villages will be washed away simply. So this sometimes or mostly can be triggered by an earthquake. That is why we put the dam burst into the category of geological hazards. Then again, volcanic eruption. In India, luckily we do not see this kind of a hazard, but in many other countries, for example, if you go to Indonesia, in Asia, or if you go to the Philippines, you will see that many of the small island nations or island nations like Philippines, these are in the Pacific Island or Pacific Ocean, and you have a lot of volcanoes. Even in Philippines, they have a volcanic center known as Philvox. So they are constantly monitoring the changes in and around these volcanoes so that they can predict if there is going to be any volcanic eruptions in the near future. So mostly these people are the geologists and from similar fields. So volcanic eruptions they took place because the molten magma due to some region it bursts outside the earth and then we term this as volcanic eruptions. So in the process, numerous new islands are sometimes created and then existing land and property and many other things are damaged. So if you happen to go to Bali in Indonesia, you should remember that the whole island actually is a volcanic island. If you go to the Marapi in Indonesia, same thing. If you go to the northern part of Luzon in the Philippines, you will also see a lot of this kind of volcanoes.
Sir,
Yes.
uh, why in that place only volcanic Europe? Why not like in India and all?
Okay, it's
What?
quite a good question. So, uh, what happens is, if you study these volcanoes, you will mostly see that these are along the places where major subduction zones are there. So that is one of the reasons why we do not have these volcanoes. So these subduction zones, even if there are subduction zones we have in along the Himalayas, uh, we do not have these volcanoes or volcanic eruptions. We do not see it here. But in their places, those subduction zones actually they lead to the crust inside the molten magma, and then they are witnessing this kind of phenomenon since long time. Why do we do not have it right now? I cannot also tell you in specific, but for some reasons in these subduction zones we do not see the molten magma coming out, especially in the Himalayan region. But along their places, especially on the Ring of Fire, we see or you see this kind of volcanic eruptions, which take place quite often. Uh, but yes, I think you have to go and study some further contents in order to know exactly why we do not have a volcano here. Okay, so if I happen to come across sometimes a literature, I'll send you. But remember that we are lucky in that sense. We do not have these volcanic eruptions, even though we have these zones of subduction along the Himalayan plate. But in the Pacific Island or in Greenland, I think Iceland, not Greenland, Iceland, and there are active volcanoes still there. And there are some of the inactive volcanoes which sometimes lie dormant for a long period of time, but suddenly, due to some activities down below, they suddenly burst out. So, as I said, in Philippines, the organization known as PhilVox, PHILVOCS, they study the size of these mountains where the volcanoes lie beneath. So, by studying their swelling and then their contraction, they are trying to find out a probable prediction or methodology for predicting a volcanic eruption. But as I said, volcanic eruptions and earthquakes, these kind of geological hazards, are extremely difficult to really predict for a meaningful information. Okay? We can just only say that there is a chance or probability of occurrence of a volcanic eruption. The same way how we say that there is a chance of occurrence of an earthquake. But if you ask me when it is going to happen, nobody in the world can right now say or pinpoint that the earthquake is going to take place tomorrow or the day after tomorrow, something like that. So this is really a challenge for modern science, for technology right now. Okay, so then again, mine fire. I think this is also a kind of geological hazard. Wherever there are open cast mines, then there are fires that takes place in these kind of mines, and mostly due to the emission of the volatile gases, including methane and many other gases. But yeah, all these are related with the geological movements or the geology of the earth. So you will find numerous other hazards that you can put into this particular category, looking in the origin of the hazards. This is not the complete list. As I said, the list continues. Then coming back to the next type of hazards, where the origin lies in the hydrological cycle mostly, that you can say is water and climatic hazards. So water, that is related to the hydrological cycle as well as the climate. uh, uh, so which also talks about the weather in the long term. Then These includes some tropical cyclones. So when or how or when we say that that is a cyclone, okay, so I think our meeting is going to end another in 5 minutes anyway. So if you want to say this is a cyclone, normally cyclone is nothing else but a depression over the ocean or over the sea. Okay, so if there is a depression or an area of low pressure that is formed due to some natural event, then the air near this depression, they quickly move to fill this void. So in the process, the air starts to revolve in the way that we normally see in the cyclone. So if it happens in the Bay of Bengal, we name it a cyclone. But if it happens in some other coastal areas, they have different names. I don't know if you know it or not. Same kind of tropical depressions, same kind of oceanic depressions. If it happens in the coastal areas of or the Gulf of Mexico, these are known as hurricanes. If it happens in the Pacific Ocean, these are known as typhoons. If it happens in the Bay of Bengal only, we call these as cyclones. But basically, the origin is same, their process of formation is same. When there is a depression in the air, okay, the nearing air quickly tries to come and then fill the void in the air pressure. But this way, these events they do form. If it forms in Bay
When
of
the
Bengal.
depression forms, sir.
Okay, so depression comes from the movement of the ocean current. Okay, nowadays you see that the world is not evenly heated. So there are all the times there are different currents in the ocean. These keeps on moving. So because of the interaction of the heat or hot and the cold climate, there is air that tries to move up and up and up, and then there is depression that forms accordingly. Okay, so first and foremost thing, in order for the formulation of the cyclones or whatever oceanic events we are talking about, we should remember that there must be a depression in the air column that has to happen. So whenever this depression takes place, the nearby air tries to fill this void. This is the origin. So why this depression takes place? There may be many other reasons. Okay, I think we are almost 148.
When
Yeah.
so when it's occur in the ocean, we call as a cyclone, and when it is occur in the coastal area or maybe in the land,
No, no,
it's
no, no,
called
no,
as a
no.
hurricane.
No, you have to see the map of the world. All these things occur in some of the ocean areas. Mostly, if it happens in the Gulf of or the Bay of Bengal. So the Bay of Bengal is where our Brahmaputra goes and then falls. Okay, the delta area. Ganga, Meghna, Jamuna. After ultimately they fall into the Indian Ocean, right? Or the Bay of Bengal. So in this particular part of the bay or the Gulf, if it comes, we term it as cyclone. The same event if it happens in the Gulf of Mexico, it means Mexico, then Northern America, the Bahamas, in the Atlantic Ocean. If this formation takes place, it is known as hurricane. The same thing if it happens in the East Asian countries in the Pacific Ocean, this is named as typhoons. Okay, so three things you have learned: cyclone,